We present a new method to interactively author terrains using diffusion models. Our framework empowers users to create a wide variety of landscapes using a combination of feature sketching and example-based stylization. In this example, we showcase the process of authoring terrains. The artist begins by either selecting a style from an example palette or uploading an exemplar terrain that aligns with their vision. Next, the artist sketches the features of the terrain, for example, a basic ridge and forked drainage network. The author may then refine and add further details to enhance the realism of the terrain. Once satisfied, the high-resolution terrain can be exported and rendered using visualization software. At a high level, our framework can be divided into two sections. First, pre-processing and training. This begins with a comprehensive data collection and filtering process. Signatures consisting of a feature sketch and style vector are then derived for these terrains and used to train an ensemble of diffusion models. Second, authoring with trained models. During iterative authoring, the trained models are used to synthesize terrains based on styles and sketches provided by an artist. Once the artist is satisfied, the terrain can be upsampled to create a final high-resolution version. Particular attention is paid to the creation of the dataset, where we train and use two CNN-based classifiers, one to remove terrain that contains recording errors, such as pixelated data, checkerboard, and stitch lines, and another to remove terrains that contained artificial features, such as buildings, roads, and farmlands. Of the 6 million downloaded tiles, corresponding to 2.2 million square kilometers, approximately one-third were found to be unusable and had to be discarded. The following is a time-lapse of the denoising process, showing progressive refinement of the terrain. The final terrain displays a coherent global structure that adheres to constraints imposed by the feature sketches and has a global aesthetic similar to the chosen style. We implement our authoring interface as a Blender add-on, enabling seamless integration with existing artist workflows. In the screen recordings that follow, we present several ways an artist can control the desired result. In this example, the user starts by drawing lines with our drainage and ridge tools. The user may then use the cliff tool to specify steep slopes, or use the flattening tool to flatten regions of the terrain. A key feature of our framework is that we can perform inverse terrain modeling. This is achieved through the automatic extraction of a terrain signature from a user-provided height map. A user may then edit the terrain, introducing new or changing existing features. We also provide the option for a user to choose the fidelity rate for signature extraction. In the interests of iterative refinement, users are offered a palette of available styles, both before and after sketch input, to control the overall terrain character. Several settings, such as number of samples, number of time steps, and desired vertical range, are available to improve the user experience. In cases where more than one sample is generated at a time, a user may generate multiple versions simultaneously, then select their favorite for further refinement. Once satisfied with the landscape, the author can then upscale the terrain using one of our upscaling models to obtain a terrain with an 8 times increase in resolution, from 19.1 meters per pixel to 2.39 meters per pixel. We also provide an additional upscaling model, which supports upscaling from 153 meters per pixel to 19.1 meters per pixel, for situations where only very low-resolution elevation data is available. As shown in this example, the cascaded application of these models results in a 64 times resolution increase, while preserving the global structure of the output terrain. Thank you for watching.